Hey guys, welcome to this new tutorial in Grasshopper. Today we're going to see a little bit about data trees and basically what is flatten and also what it's graft, which are functions that had to do with the data path, right? Um, so let's start by doing a curve, and let's start getting some information out of this curve, right? So I'm going to do a curve. I'm going to connect this curve here, and you see that if we put a comment and we can see the content of that. This number here is describing the data path of the element, right? So if I also use the param viewer, right? The param viewer, it's a node that allows us to see the path structure, right? So we can actually right click and select to show the tree structure. So in this case, we're looking at um, and this first trunk of the tree, meaning that we are basically in the very first path of the tree, right? So let's start being consistent and show this information as we do some operations to this line. It's not important what operations I'm doing, it's only about to understand how the data pattern in a way starts changing, right? Um, so let's do a divide operation, and we're going to plug the curve here, and you see that we have divided um, and the curve in several points. So I'm going to copy and paste now this, and you see that what I have created here, it's a list of points now, right? And if we look at the path, we are basically in the second branch of the path, meaning that these points live inside this curve, right? So okay, that might not mean anything right now, but I mean that's the way it's been structured, right? So we should be aware of that. um, let's do a quick operation of decompose these points. um, so I'm just gonna basically decompose these points and add a little bit of value to the set and do another point. Sorry. So I'm going to recompose these points, the x, the y, the same thing. But then the set, it's going to be slightly offsetted. So I can also edit this slider to be slightly bigger, right? So for instance that, right? And I can do the line now between these points and the first points, right? So I have another line. And I mean, as much as I can just look at the data path of this line, it's the same, because in a way we have a line per point where we're still kind of in the same path, right? But what if we divide this line now? I'm going to just do the same operation that we did divide here. And you see that we have divided the line, each one of these new lines, into a sequence of 10 points, right? So let's look at the data path of that now. And you see that now we're getting this kind of segmented line here, and we start getting something very different, right? This structure is saying you have a list per line, right? So now the branch is showing me this branch structure, where I have the trunk, where I basically got the line representing the very first branch, and then each one of those branches has its own individual list, right? So this is when we start seeing this kind of segmented lines, and also we start seeing that our lists have these kind of blocks, right? So we have this list for the second line, this list for the third line, and so on, right? So that's something to be aware. I mean, as you are kind of developing your data, um, there is a structure that can contain that information, and that's like a tree structure, right? And there's lots of operations. If you look here in the set trees, there's a lot of operations that you can do with trees, right? Some of the most common ones are the ones that actually you can just right click and use here, right? But Instead of doing that, which is, I'm going to be a bit more explicit, because you can call these functions like flatten and graft constantly by using a node, right? So flatten tree, that's exactly the same that's saying flatten, and then also graft, right? So if you see the icon for flatten was a little trunk, like cut trunk, and then the tree, it's actually a little kind of seed, or like a branch growing, right? So let's look at what these are, right? Um, I'm gonna just leave this one here, but let's look first at flatten. And flatten, what we'll do is just basically literally flatten the list, right? So you see that we got rid of all the path structure, and it basically made out of all these points a big giant list. So it basically merged everything into one list and also removed any sort of structure, right? Um, so that's useful sometimes, especially when you're dealing with data matching, right? When you need to connect elements of an individual from one to list, right? And you need to do data matching, you need to have them in the same branch. So that's important. Um, I'm going to show you what graph does, but I'm not going to do it here because that would be like very confusing. But let's do it over the data created from the flatten, right? So imagine that this data, we're going to graft it, right? So we're going to just say graft here, and we're going to plug now the graph node. And you see, well, this is kind of a lot of nodes, but like what graft is doing is basically doing for each individual element in list, it's going to create an individual branch in the tree, right? So it's going to add a level, but it's going to position each one of those elements in a branch, right? And because here we have like 120 elements, this kind of graph, it's difficult to kind of see it. So we could actually um, plug something else. Let's say these lines. Um, yeah, that's kind of better, right? So if we do the graft to these lines, if we want to see that, what does that list contain, we could just plug this one here, and you'll see that we have 10 lines, right? So those 10 lines, each one of them has been created an individual branch in the tree, right? So between these two operations, you can actually solve a lot of problems in Grasshopper. But you might not see yet why is that important, right? So let's do an example in which one simple script that I was working with a student, and I think it's a good exercise to understand why graft and flatten work and where can you use each one of them. So I'm gonna just leave this here, and I'm gonna continue creating one simple script that will actually show us when do we use flatten and graft, right? So let's create something like a rectangle like this. So it's a nerve rectangle, and I'm gonna copy this guy a few times. Right? So, and the other thing I'm gonna do is just maybe in the top view, let's imagine that I have a line cutting through these guys like this, right? And I want to just, maybe I had these elements had been trimmed already, right? So let's the script that I had to deal with was how do I make out of these rectangles um, basically a capped rectangle, uh, but maybe a script that would apply for all of them, right? So just picking like this corner point on the or the point that it's kind of in the lowest in this cut here, in a way create a plane out of that, cut, and basically recreate this rectangle, right? So let's do a simple script that would do that. First we're going to do it for one of these boxes, and then we're going to see what is the problem and what doesn't it apply to several boxes, and in a way adapt it using graft and tree to to make it work for several boxes, right? So I'm going to just bring a brep, which is a representation of a polysurface. So set one brep, there we go. And I'm going to hide my object, right? So I'm going to explode this guy with brep components, right? And I'm going to pick with item, list item. So I'm looking for the vertex, right? So explode or brep components. If you're looking for this explode node, remember it's brep components. Brep components. Or if you type explode, oh my spelling, it's not good today. So brep components, it's then it shows as an explode node, but that's the one we're working with, right? And this will give me the faces, the edges, and the vertices of a polysurface, right? So that's really handy. Let's create a slider that is from the type integer and edit it to be from 0 to 10, and just basically search with, if we just click on this item now, we could actually move the slider and you see that the point is being highlighted. So we're going to just navigate and try to find which is the point that we want to work with. And I think we're going to be working with this point, the lower corner point, right? So you can see that we have determined that that's the point we want to work with. We're going to do a plane that it's a YZ plane. So YZ plane, and I'm going to apply this plane to that point, right? So I have a plane position in that point, and I can do now, if I go to intersection, right, mathematical brep plane, right, that would uh, make a section between a polysurface and a plane, right? So I actually do have a plane. Oops. Right, I do have a plane and I do have a polysurface, which is the original polysurface, right? So that's pretty good. So let's we have that. There's several ways of doing the other side. Like I'm not gonna trim, because if you think in modeling terms, what you would like to do is just use this curve to kind of remove this extra geometry. But in a way, what what I think the way of thinking in Grasshopper is just how do I recreate a clean geometry, like I recreate a box with this information, right? So I could do this same operation for the other side, but just for the sake of showing a few more nodes, and this idea of like collecting information and recomposing information through these items, even though it's a bit kind of manual and maybe doesn't make too much sense sometimes, I'm gonna just do it like this. I'm gonna just copy this item element, but I'm gonna replug now edges, right? So I could just basically, if I kind of hide now the preview of that object, um, let's see what we get. We are highlighting this edge. You can see here, maybe that you can't see it very well, but if you move around now, I'm highlighting that edge over there, right? So basically, this edge over here, 4, is one of the ones that we want. We want to just collect this, all these edges on this side, right? So you can actually copy this thing a few times around, and then you will need 5. You will need also, because 5 is that one, you will need also, I think it's 3 and maybe 1 or 2. Let's see. So 2, it's not the one, and 1, it's the bottom one, right? So that's pretty good. We have all the 4 edges, and now we can merge them. So I'm gonna merge them starting from the top one and going like that, right? So this one first, then the right one, which is this one, then the bottom one, which is this one, and then the lower point one, right? So I basically merge them, like recreating these curves, and now I can join the curves, and I have this kind of, if we want to check what we got out of that, just to make sure that it's working, we have a polyline, right? which is a polyline that would kind of, we would be able to join, or like loft in this case, with this section curve, right? So I can do loft, and if we do loft now, you see that loft requires two, so I'm pressing shift to connect two nodes to one. We don't get the right solution, so maybe I have to flip the curve. Oops. And I think that works fine, right? So let's get rid of the original. So there we go. We can see that we have a rectangle. I mean, very simple. I mean, maybe a lot of trouble just to get this simple operation, right? But it's not the purpose of just to show this script working. It's actually like, how do we change this script into like working for several objects, and that will actually be clear how to use graft and flatten. And also we're gonna do cap holes, right? So cap holes is gonna just give us the final closed solid, right? So we have that. Um, so that's pretty good. Just I'm gonna copy the whole network now, just to make a variation of it. So this works for one object, right? But what if this same script I want to just, let's say, set multiple breps, right? Instead of just setting one, right? So I'm gonna just click here, and I'm gonna select the brep. So I'm gonna select these three, I mean these four, sorry. And you see that we have a few problems really, right? And the things are not working well, right? So let's take a look at what's going on here, and then let's try to solve it. So we are starting now with 4 breps, right? So when we explode these elements, basically we're getting already a tree structure. That means that we have so many vertices for each one of the breps, right? And they are structured this way, right? So that's something interesting to be aware. So when we pick number 4, we are picking the element for each one of those lists, right? And we are making a plane for each one of those lists again, right? So we have 4 planes now, we just not have one. The problem that we're having is that, in a way, this section, we have these breps as a list, and we have these planes as a tree, right? So here we need to do data matching, right? So we need each plane to intersect with each one of the respective breps, right? And in this case, it's easy because we can flatten. I'm going to just flatten the planes, right? So if I pick the planes and I flatten them, you see that now I have 4 planes. And I'm going to just try to move this around so we have space to work here, right? So the planes that I had before was that, right? And if I flatten them, now they are kind of just a list, right? And if you know about data matching, as we saw in some of the first tutorials, the data matching here, it's happening one-to-one. So the first element is going to match with the second element, I mean, with the first element, second with second, and so forth, right? So instead of using this original list that it's in a tree structure, I'm going to just use this flat list, right? So that should give me the first mistake that we had like several cuts per object. And in this case, we will have just one cut per object, right? So that's pretty good. The second problem has to do with the loft, right? So this part is going to be different. It's not going to work if we just do flatten. So let's see what is the problem with that. So I'm going to just remove that. So the section is working, right? So let's look at the bottom bit now. So what am I having here? This item 4, again, you're basically collecting a line for each one of the breps, another line, and 4 lines for each one of the breps. So here you have 4 lines for each one of them, right? When you join them, you create one polyline, which is the backline, like for each one of them. And from the other side of the network, basically you are getting also 4, well, one polyline for each one of the in each branch, right? But if you see the path structure, you see that we're in the third branch here and we're in the second branch here. So this is like, it's not going to work, right? We actually need to do something here um, to solve this issue. And we could see, well, what is the first approach? Why don't we just flatten both? And we'll see why that might not work, right? So if we flatten the first one, we get that, right? And you flatten the second one, and now both are in the same level, right? You could say, oh, that's perfect. I could just connect this one and that one, and that is a big mess, right? That's because the function loft works already with a series of curves, right? So in a way, what you're trying to do is connect the first one with the first one, the second one with the second one, and the third one with the third one. But because loft actually works with a collection already, it will basically make a merge of these two. So basically, we could see that explicitly like that, like a merge of these two. And it's gonna do a loft between these 8 lines. And that's not what we want. We just want to do a line between the first one of this list and the first one of the other list. So here's where I'm gonna leave this flatten here because it's actually useful to flatten the list first. And I'm gonna do flatten and then graft, because flatten will make them both go to like a level, sorry, graft, right? And I'm gonna do the same for the other one. So if we look at what we did in flatten, we were just making the list, the original list, whatever structure it had, flat, right? And now when we graft it, we create basically an individual branch for each one of the elements, right? So when we do that the same on the other side, this is what we had, this is when we flatten, and this is when we graft, right? So I mean, in this case it stays the same, but I'm just going to be very clear that we're kind of following the same structure, both flatten, both graft, and we are having now a merge. That you see that the merge that we're going to get now, it's very different, right? It's saying the first branch of the tree contains 2 lines, the second branch contains 2 lines, and so forth. And in a way, loft now will understand that you're trying to loft these 2 lines, these 2 lines, these 2 lines, and these 2 lines individually. So if I connect that here now, you see that I could basically hide this geometry. And even I can just hide the planes, right? So there we go. So you see that because I was using graft now, I was able to kind of make a list for loft that would apply for several entities. And in a way, it's lofting between just these 2 lines here, right? And that would happen for any number of elements. I mean, you can do this script now. It's kind of, it works for n number of elements, like as many as you want, while this one only works if you do it in one element, right? So that's something that is useful to know. These path structures really help you out. I mean, you have to be aware of the data paths um, to start being able to kind of apply scripts to kind of multiple objects, right? So this is for this tutorial, and soon we're gonna start seeing some new stuff. So I'll see you guys soon.